to everyone, and thank you for joining us on this fifth session of the webinar series of the Nigerian Society of Engineers Glasgow branch. My name is Emmanuel Salifu, and I'm the Publicity Secretary of the branch. And it's with great pleasure that I welcome you to this very special, and I think the last of our webinars for this year, 2020. It's been a very wonderful year. You would agree with me that we're able to have this kind of events across the world, wherever you are. We've been joining each other week after week throughout from the mid of the year, I think, for this branch, and mostly across other events around the world. We've been able to access events like this due to technological breakthroughs of our time. And of course, the effect of COVID-19, which I think this might be something like a positive side for that. Part of what we're discussing today is another great technological breakthrough that has helped engineering a great deal. You know, we recall the days of trying to create our designs by drawing using the T-square, the drawing board, pencils, trying to carve our models in very manual and less technical ways, and the challenges we have in all of that. But there's been great advancement over time. And today we have more tools, devices, equipments, and technologies that can help us do this even far better than you could have imagined many years ago. And to talk about this today, we have a great speaker, someone who's experienced and versed in this area. We'll be talking about speaking to this topic of computer-aided design, engineering, and manufacturing, CAD and CAM in modern industrialization. He's not just going to be talking like every other presentation. There's also going to be a practicum session. If you don't know what that means, then just hang on. You'll see that very shortly. So without further ado, I'll just go straight to the program lineup, which we have today. We'll have the welcome remarks from the chairman of the branch, who will be coming on shortly, and thereafter I'll introduce the facilitator. And then he would go on with the program, the talk, the presentation, very short presentation, and then the practicum session. And then we'll have question and answers. Just to say that if you have questions while the talk is going on or the practicum session, feel free to put them in the chat, and then we'll pick them up from there. My colleague would come on at the question and answer session and gather them up and get the facilitator to speak to them all. And then we'll have final remarks from the facilitator and everyone, especially, and anyone who gets interest, just to look at how we can make use of this knowledge going forward in the future. And finally, vote of thanks, announcements, and closing. So I will be handing over now to the chairman of the branch for his welcome address. I invite Dr. Oluseun Adedinro, the chair, NSC Glasgow branch, to present his welcome address. Over to you, Chairman.
Yeah, thank you. Thank you, Dr. Emmanuel. Thanks, everyone, for joining us today from wherever you are joining us from all over the world. Thanks for this practical, as Dr. Emmanuel mentioned, this is the What Actually Changed Engineering, CAD and CAM. And this has gone a long way over the years. Most of us, we use this pretty much every day in our work. And also want to say that, you know, for the health and safety, this is a critical because this is going to last for more than an hour. If there's any time you want to stand up to stretch your back and all that, please feel free to do that and get water or a cup of tea and get something to make you feel comfortable. Yeah, we really love that you are joining us today once again. And also, if we have the NSC executive among us, please, if we can't recognize you just now, please drop us a message. We'll definitely do that as before the end of the program. And another critical thing which probably we want to let people know, us as a Glasgow branch, we are the only branch, NSC branch in Scotland. And if you are joining us today, no matter which part of the world you are joining us from, please feel free to contact us if you want more information about the NSC membership, especially if you are living in Scotland and its surrounding, please contact us. We'll be able to tell you more about what we do, what our vision is as a branch. And in a way, part of our vision is to see the Nigeria growing. We want Nigeria to move forward. We want to go to another level as a country. And, you know, so all we need to do is to do what we can from there to, you know, to make and want to develop our young engineers as well. And without wasting more time, and also I want to use this opportunity to recognize all our executives, the main executive of Glasgow branch, and all our subcommittee executives as well. And thanks for joining today. And wherever you are joining us from, as I said, even all the branch chairmen from other branches in the UK, Manchester branch, Dr. Books, you are recognized. And Dr. Popola, you are recognized too, sir. And Engineer Patrick Ibidoyin, you are also recognized. Thanks for joining us today. We appreciate you. And while you are sitting tight to enjoy the webinar today, please feel free, drop message on the chat room if there's something that you want to know more about our branch especially. And we love you, and we hope that you enjoy this webinar. I can assure you it's going to be a fantastic one. Thank you. And now, and Dr. Emmanuel, you can continue from this end. Thank you.
Thank you very much, Engineer Dr. Oluseun Adediran, the chairman, the pioneer chairman of the NSC Glasgow branch. Right. Our speaker, our facilitator for today, actually, as he prefers to be called, is an executive committee member of the Nigerian Society of Engineers Glasgow branch. So this is our own presenting today. Engineer Sharp Ugwuocha, MNSE, is a former senior R&D mechanical design engineer with Halliburton in the United Kingdom. He's an inventor with a number of patents registered in Europe and in the United States. He's experienced in research and development engineering and manufacturing methods, engineering design team leader on several equipment design and manufacture projects in the United Kingdom. He's an expert in computer-aided design engineering. He's experienced in new engineering product development, NPD, from concept. He's an expert in design for manufacture, DFM. He's a lead audit engineer in manufacturing engineering to ISO 9001, an engineering representative in computer-aided manufacturing engineering. He holds an MSc in engineering from the Robert Gordon University in Aberdeen, UK, and a Bachelor of Engineering, BENG'G in mechanical engineering. He's a STEM ambassador here in Scotland in the United Kingdom. He's a coach and trainer in finite elements analysis, FEA. He's an analyst in computational fluid dynamics, CFD. Engineer Sharp is experienced in many design and manufacturing standards and codes, including CGMP, BS 4825, NACE, API, ISO 5, GR Grade A, and many others. He's experienced in engineering corrective notification, ECN processes, and PDM systems. He's experienced in handling engineering non-conformances, NCR, and corrective and preventative action reports, CPAR, in engineering production. Engineer Sharp is heavily experienced also in multiple 3D computer-aided design software packages, such as SolidWorks, Creo / Pro Engineer, AutoCAD, among others. He's a registered and certified engineer with the Council for Regulation of Engineering in Nigeria, COREN. Dear friends, guests, I welcome our facilitator today, Engineer Sharp Ugwuocha, as he takes over the screen and the microphone.
Thank you, Dr. Emmanuel, and thank you for attending today, all our viewers and colleagues and all the executives, people that are our friends in high places. You're welcome. I will just share my screen right away. Right. Once again, to the Executive Committee of the Nigerian Society of Engineers Glasgow branch. Thank you for giving me this opportunity, and welcome everyone. Computer-aided design engineering and manufacturing, it's been have had a successful and great journey to this moment. And someone asked a question that the first time people went to the moon, and perhaps they designed or came up with all those spacecrafts with slide rules and all that, got me thinking, say, which CAD tools did they require to do that? But the question is, how much did it cost them, and how long did it take them to prepare and do all that together? That's food for thought. So today, I'll be presenting just basically 6 sections. The first parts, I will just present the historic and statistical aspects overview, and then I'm expected to spend 2 minutes there, and then I should have actually taken all those times away, but forgive me for that. It's cool. And we'll talk about CAD and the industry, and then additive manufacturing, which is 3D printing, and then we'll talk about the CAD-CAM benefits. Each time you see, for those who are just joining us afresh, CAD is computer-aided design, and then CAM is computer-aided manufacturing, and then we go through to, I want to zero in finally, after we talked about the engineering opportunities. Please pay attention, there are quite some engineering opportunities, and then I'm hoping to zero in on some models where we'll spend more time showing us a few things around. There's a pet project I'm doing. I want to bring it up on board and show us to use that as a demonstration. Okay. The history, I just wanted to present this page to show. This is from Statista. It's a 2020 output there. There are other statistics out there that is predicting a little bit more optimistic than this one in terms of where CAD will be doing, So it's estimated just from 2016, as you can see on the slide, just from 2016, the market revenue associated with computer-aided design engineering was about $7 billion US dollars. And just in the past 4 years, it's estimated to be around hitting that 12 mark already before even 2023. But this was a projection that by 2023, it will be 11 billion. And then in another 8 years' time, it would have doubled what it was in 2016. So it will be around a $14 billion market revenue associated with computer-aided design engineering. Now, the question I wanted to do, place side by side where we are in Nigeria as a nation, but I couldn't fetch that separate statistics to place along with this, how well we are doing in terms of computer-aided design engineering. For those who are not Nigerians, permit me to be biased to Nigeria today because for obvious reasons, Nigeria Society of Engineers. So the statistics I would have loved to add there is the market share that is associated to Nigeria. But unfortunately, I wasn't able to pull any figure in that direction. So industrialization, that's modern manufacturing and CAD-CAM integration. This is the picture of how today's industry is looking at, like, in where people are serious with CAD and CAM. And the pictures there, in fact, the lower right hand, this one, is a very close match to where I work. And it's showing that things, of course, those Mazak machines and production units are very efficient and they run on CAD. So you could get your computer model generated, and then some of them can actually do even inspection of the part, meaning you can ignore, except for audit's sake, you can ignore the aspect of drawing and just produce from what is called the IGS model or step files. So you could feed it into the system, and the system reads it and then begin to produce whatever you're producing. Once again, I'm going to be a little bit biased. I know CAD is wide. It will be touching some aspects of construction, civil engineering, structural engineering. But because I'm zeroing in on manufacturing today, industrialization and modern manufacturing, I will be a little bit more lean to the mechanical, electromechanical side of things for the day. So that does not mean that people who of the other aspects of engineering don't have relevance for CAM, but my demo today may be biased on that side of things because we are looking at industrialization. And we cannot talk about industrialization, whether it's in the area of mechatronics or cabling, PCB, without CAD today. It's not just going to happen. So most of everything you see, most of them is generated by CAD. And I've just put those pictures because they're like the drone, they are the in things now. And like I promised, I'm going to show something at the end of the day along that line. So the HVAC industry also, which I've done a little bit of pieces of this, it's also benefiting a lot from CAD in the modern, in the last 20 years. It's been heavily dependent on CAD. If you look at the, again, I would predict that more is going to be happening in this industry. Heating, HVAC, for those who may be non-engineers here, will stand for heating, ventilation, and air conditioning engineering. So that industry with the sheet metal side of things, it's heavily duct systems. If you walk into a supermarket, if you look up on the ceiling, you will see it's well ducted. I think a few more may be happening if the virus had persisted, and then looking at how we can, I'm even predicting that future building regulations will pick up a lot of things along that line. So that's an industry that is promising. So you think about the agro-allied industry, well, whether it's a farm machinery or the trucks that carry dairy products and all that. So there's virtually anything you could look now that you could produce if we want to industrialize in earnest that would not require CAD or aspects, very pretty aspects of CAD to be used to be efficient in doing that. Done a little bit scratches of that kind of dairy tank going on there. So there's quite a lot of CAD coming in there to optimize the designs and even the production, manufacturing of all those things. So every industry we look at, there is aspect of CAD that is very necessary and would be applicable. And of course, the power generation industry, I was running some training with some people, and then we're trying to do some turbine blades and all that, rotating equipment. I've done some mini turbines for some downhole pumps and all that kind of stuff. So it's all heavily dependent on CAD, simulating flows around them. And I would virtually say there is no way one can do these things these days, even in the 21st century, without CAD. So CAD, anywhere you look. And of course, the future of the automotive industry, which is electric cars, it's also going to be CAD, plugging into CAD. So whether it's the electric traction motors or the power electronic controllers and all the transmission system, you could see the footprints of CAD everywhere. Okay, so pharmaceutical industry, Yeah, I think the top left, this one, some of my products. I've done designs in this before. So CAD. This is also another very good branch of sheet metal work. It looks as if sheet metal is CAD, heavily CAD dependent to generate all those sheet metal work and panels. Or if you're talking about the clean rooms like this, all heavily CAD. And that's okay. So in the medical devices, it had virtually that's actually a computer-generated model, CAD model of that's intensive care unit or scanning system that we have there. More few places where CAM and CAD are playing significant role, even in biomedical engineering and doing some kind of automation with that. There are some times that we don't have all the money to perform tests, series of tests and of tests that we could use some CAD to, go from point A to B. If we have done the basic we need to do and then set off from there, we just use CAD to do the rest. So whether it's aerospace industry, defense industry, oil and gas industry, building and structural engineering, renewable energy, all process engineering, whichever angle you look, marine and shipbuilding, there is, as a matter of fact, all this list of industries, there are some, I think I'll try in one of my pages to provide a few. I don't know all the hundreds of CAD tools or packages that are relevant to, I just mentioned a few to all these different industries. But as we'll be talking about industrialization today, with regards to general product creation and development, I would say it's high time we start embracing CAD. And even if it's not going to be at where we're engaging it in the industry, but with the way things are looking in the future, on a personal level, I will drive home that point where I'm saying on a personal level, we need to be picking up on CAD. So benefits, seamless design to manufacturing process, quicker time to market. PDM there stands for product documentation and management, or products lifecycle management. CAD supports it. Most CAD packages now have a way they integrate to a Vault or systems like SAP, SAP, or Windchill. These are places you could control the way document or designs are going, some that are pre-release or before they get released, and then they get revised up, so you could document everything. Prior to that time, it's going to be papers and you have to print drawings and have stacks of drawings. But then if you change that, if you change your design, you don't know how you can go back to that paper and correct. You just have to. But these days, CAD systems work with most product and documentation management systems, and then they're seamless. You can line them up. You can actually detail out all the attributes and everything, the specifications, the coatings, and everything you're going to do to a component or an assembly. You publish it all there. So it saves time. And if you're going to have to change revision and update them later, that's fine. So quicker conceptualization, I'll demonstrate this to you because there's an idea that had been coming to my mind. Because of CAD, I'm able to, generate those concepts and then also generate the visual models of the concept I'm looking at. And then I'm able to go there, make changes to my design intent. That's flexibility there, push it around, move things around. So CAD's been able to offer those opportunities to enhance innovation. And also, if you're trying to conduct feasibility study for what you're designing, just not when you are pulling the ideas together, you're able to run some feasibility study with the aid of CAD. So that is possible these days. And if you launch a little bit deeper into it, you could use CAD to highlight areas of product imperfection. As we are thinking about industrialization. So nobody wants to be producing at losses. So there are some things you can catch up on time with the aid of CAD to, you could see where things are clashing, where there will be manufacturing defects. Most of the CAD tools now, you can run simulations on the manufacturing process, and some of them, as you're taking it from CAD and feeding it to CAM, you could see where it will suggest to you times that if you follow this production route, it's going to take you time or more time. Whereas if you follow the other one, it's going to take you less time. Excuse me. So, and then be able to optimize your times and give you better value for your money. So you're also able to run some basic analysis like finite element analysis. I hope I'm going to run one today, just a quick one, and then CFD. Might not be able to get into that because it will take longer time, and do some tolerance study for your assembly fitness and all that. So CAD is very, very helpful. And in line with the future is looking in the direction of 3D printing and additive manufacturing, basically. So, and automation, AR, which is what is the world we live in now. So CAD is positioned to flow along with that. Now, I'm going to say something on this. Let me not waste time and make a call here. I see when we are talking about industrialization, let me just zero in here. There's something I might be wrong in my prediction or in my call, but I see that happening. Now, the future may be going in the direction that industries is not just going to be that there will be one big industrial cluster in one locality, heavy industry. That some aspect of it may still exist, but I'm seeing that the future is going to be that I can be producing some things in my backyard, in my garage. So imagine 80 of us here, out of 80 of us here, 40 of us or 50 of us are producing some items for ourselves. So either we are producing in a commercial quantity that we are selling, and that's part of the industry, or we are producing for ourselves. For example, if I want to make a toy for my plate for my use, I could actually just print them, 3D print them. But if I don't have CAD, I won't be able to generate the money. I will need to meet the services of somebody, so I would need to engage the services of somebody. But if I can generate the plate, custom make it to what I want, and then produce it in my garage or in my backyard. So that would be the future of the industry. I don't need to go to the market to buy plates or toys for my child. So that's what I'm saying in a nutshell, is that the future is looking at the industry. When we are looking at it, there will be the heavy side of industries, but there will also be small, apart from the small scale businesses, but there will be some individuals that are industries themselves to some extent. So let's look at that. So automation is also along the line of CAD. Okay, so CAD packages, if you're the way this is just an advice. If you're getting into CAD, please, it would be good for you to know the ones that are very, very prominent in the kind of things you do. The kind of things you do, like if you're in mechanical engineering, you're dealing with components. I think these are my tips. By no means, the list is not exhaustive, as you could see on the last note there. Mechanical engineering, SolidWorks, PTC Creo, used to be called Pro Engineer, CATIA, Inventor, and CMS, NX, AutoCAD. You see, I think the other ones, when it comes to mechanical components, I think you will have a feel on this. There are also free CAD versions out there, free CAD, that will be, you can easily get. Some of them are expensive at the moment. And more and more as we are growing in CAD, some of them are becoming cloud-based so that you can just download them and use them or subscribe and use to the extent. So, and it tends to be that once you know a little bit of this, you can do the other ones to some reasonable extent. Civil engineering and structural engineering and architecture guys, you look quite a lot of BIM system out there, Revit, AutoCAD, Aveva, Style, Point Cloud, Myra. So this, you may need to be familiar with this one. Marine shipbuilding, Tribune, Rhino, you know, so the list is there. If you're in electrical or electronics, there's EGO, KiCad, WSCAD. There's also SolidWorks electrical, which is very prominent and helpful in, you know, some of the things. So chemical engineers and process engineering guys in plant design, I spend high Cs, I spend plus, Aveva, ANSYS Flame, very, very useful. So you would need to, the Flowtran. Once again, this is not all of them. There's quite a large amount of them out there. Okay, so let me move on. Right, industrialization and CAD opportunities. I want to speak about this one before I get into the practical side of things. The big areas, I call them the big areas for manufacturing and industrialization. Precision casting and molding, there is quite a big area. If you look around you in the house or where you are now, by my side here is printer. Some of the parts are injection molded. The laptop you're looking at, if it's not like some of them, most of the parts are injection molded. The keyboards, they're all injection molded somehow. So you then go to the bottles, the cream bottle, everything, you know, the toys, most of them are injection molded. So that's a very big area that we could be plugging in. And you're looking at CNC machines and precision machining for some kind of tools and equipment. It's not just only the lathe machine. You saw from the first picture I showed there, that's right, it's moved on. So these Mazak 556 machines that can rotate, cut and drill holes in very unbelievable angles and all that. So we need, and some of them are getting into automation too. They know the sequence, they can cut things. So you can use CAD to drive these CNC machines and finish operations that would have taken ages in a short time. Now, the sheet metal industry also, like I was showing in the picture, whether it's HVAC, pharma, or food industry, some of the picture I showed you was a kind of industry, or maybe it's still coming. So building some ovens and some of these bakeries, small bakeries that we are going to be having springing out as we industrialize. They are very helpful. You could generate your concept and start looking into it. Then additive manufacturing 3D is a big opportunity, like I've mentioned, having your backyard or your garage as a factory for yourself. So CAD modeling and layout for engineers, I use this a lot, and I used to say to this person, I didn't want to get to a point where I would just be doing engineering without CAD again. So to some extent, I still want to do like layout myself, whatever I'm producing. I should be able to just do a quick exercise on this left side, a quick model on that, and get on with it, just to do the demo. And I was doing some plant design or layout of piping, but it was long and plenty. So I said, well, maybe I can show. If I have time, maybe during the question time, we can just show how you can push some layout around. Maybe you are building a small fertilizer plant or a small drip irrigation farm in your garden and all that. You can use CAD to just size things up and push it here and there. It sparks innovation, and that's the direction we ought to be going. Okay, and I was generating this ice bike also, I will look for it and see if I can pull it, but that's by the way. So this is an exercise I was I gave to some people I was training somewhere, and some Nigerians, and they did very well to generate these ovens with the little I have taught them. So that was very good. The students responded very well, or the trainees responded very well. So it's doable. Okay, and finite element analysis and simulation, I should be able to do some today, and then some of the CAD files come with calculation package along with it, like MathCAD. For those who get the PTC Creo, who are familiar with that, you get that one free in that. Okay, so CAD Practicum, I think I've spent so much time talking. I think I might need to just hit. Let me start off with the block engine just to whet some people's appetite. That's what I'm looking to achieve here, is that sometimes if you master it, it doesn't take time. Okay, it's just the aspect of modeling or the CAD drafting for the engineer. It might be saying, well, it doesn't belong to me. But let me say something here. Let me go back here on CAD opportunities, because I was going to talk about local and global opportunities here. There's something we've seen happening in the UK. Most of the engineering firms, they don't pay 20, 30 pounds per hour to engineers or their drafters to do the job here. What they do with Indians here or Polish guys here, what they do is that they subcontract those engineering support functions to countries like India or Poland. Now, they pay them in their rupees or in their own currency, but that's good money there, but very cheap compared to the price they would have paid in the UK. I think as a nation, Nigeria, we need to plug into those opportunities and train ourselves to be able to use CAD so that those opportunities will come our way. And whether we like it or not, the opportunities are going to be coming more and more, even when it comes to providing CAD files for even 3D printing or whatever. If you know it, you get a job. So a graduate or somebody from the Polytechnic who is looking for work to do, and if he can learn and grab this CAD and can do it at a professional level, he will be, a company in the UK can, if there's a design office in Nigeria, can engage them and comfortably pay everybody there 300,000 naira per month easily, because it is far cheaper than what they'll be paying engineers or drafters to do that same job here in the UK. So those opportunities are, and there is nothing with this E-world we are living in, there is nothing stopping people from blazing in Nigeria and working for a country, a company in the UK or in the US. But you must know you are doing. You must be grounded. Operator, can we get is coming on. Okay.
Can we please for my mute, please? Thank you.
So there are those opportunities, there are global opportunities, and also local opportunities to support industries at home and in generating ideas. So let's get cracking. I will do a back engine exercise quickly, and I'll do some finite element analysis at some point and demonstrate injection molding in a way. Okay, and then I think I should just go straight, because of time, to after this, I should go straight to my pet project and just be able to demonstrate what I've been doing. Right, so I might hit, this is what I'm trying to do in my pet project. I'm trying to provide a budget intercity transportation. Normally in computer design, you have your design requirements where you list, and I want it to be eco-friendly. I want to overcome the poor road infrastructure we have in Nigeria. This is specific for Nigeria. I want it to be a multiple passenger carriage. I want to capitalize on Africa's resources. and I want to utilize additive manufacturing as much as I can do. And I also want at least a minimum of 80 to 100 kilometer journey distances, low, medium level license to operate, and reduce rechargeable duration, and provide some extra fail-safe feature in my design. So watch this space. I'll be presenting something along this line. And okay, before no question yet, let me do the bit of demo. Right. I'm sharing my screen. This is actually a circuit, something I was using for training. And before, let me just go on and start off with the engine block. So because it's a car practicum, I just wanted to demonstrate the ease with which we can do this thing. So bike engine. I'm using the model, the software I'm using for today in this practicum is Creo 6.0. It's the same as SolidWorks. Some of them are easy to get, some of them are not. Let's say I'll call this one today is what, 05, 0212. So that's me. I just want to demonstrate that these things are not as tough or time taken as it is. So I'll be doing similar to that engine block that so let me flash it off again, something like this. Just as a demo for today. Right, so I'll come off and then the aim or what I want to achieve with this is speed. In the time scheme of events, this could all happen quick. So most CAD packages, you just do a simple sketch. And once you do a simple sketch, it should be able to, as we accept it, it should be able to default to a 3D package. Sorry, a 3D shape automatically. Let me make this 250. So that's the height. I didn't give sizes to that one. So that's you're already modeling things in 3D. It doesn't take, well, I could round off sides if I want and do some demo like that. And then I could leave them at 10, it's defaulting at 10. I'm okay with that. Okay. And then I could come here and I could produce holes if I want on the surfaces. And let's say I reference that. And I also could give it a size if I want, 100, just, and then I could tell him this time around, you're reversing and you're removing material all through that. So that's it, hollows it out if I want. And then I could, it's always good to label your model as you proceed. I could say this is my raw cast or whatever it is. And then the second one is my cylinder hole for that bike engine block. And then I could also go ahead and cut a couple of holes. I might not make it because of time. I may not make it exactly what I had there, but something close to that. So this is going to stay. Well, let me dimension it from this other end, if that is, and then I could, I hope this is coming, you're seeing what I'm doing, I'm hoping though. So this is just to demonstrate how quick things could be. Let me make it a little bit funky here. And then I'll trim off these parts. most of these model things have a way of telling you when you are, for those, I know people are going to be asking me, I'm too fast or questions later on. We will deal with that later on. So that is going to be some later.
You're mute.
Engineer Sharp, can you unmute yourself? I don't know how you get muted there. Will you mind to unmute yourself now?
Okay. So
Yeah.
thank you very much. I
Brilliant.
just suspected I can't hear myself again. Right.
Oh, super.
So in things like this, we could create. You could do what we call reference planes and create a few more that you want to position. Let me just do 20 away from there because I want to start from there and do fins. Now this is when it gets interesting because it will make a lot of difference if you learn these things, and we can just, I'm going to run an FE on this one just to check some basic things on it. Okay, and then I could reference my edges as the case may be. Right, I'll make this fins. I'm creating the fins now. I'll make this 350 and I'll make this one 250. So those will be the wide fins. And I'll only make them to go back with 5. So it's going to be small plates there. Right. So in these kind of things, you are going to, CAD will give you opportunity to just create one and be able to multiply them if they're identical. So I'm going to just round up this, round up that one. There's a way you could do this even within that. So this basic drafting things, we may not go into details today. I'm going to group this, but I'm just wanted to demonstrate that it's quicker. So I'm going to pattern this, moving in this direction. And I want a dozen of them. I want a dozen. And I want them to be 20 space or 18. As it. And then that's pretty much. So it's quicker. So I'm almost there with my engine block, except for the holes. Could do some couple of holes here just to simulate what that one is. And obviously I'm rushing, so I'm not. So let's say that's 90 and that's 40. The hole size is 20. And I could so this kind of quick drafting skills, engineers, I think my benefit of keeping on to my drafting skills is so that I should be able to generate my layout designs if I want to do that, and then check any concept I want. I could just try them out and check them out and stuff like that. So as more you get senior into these things, you don't need to do stuff like this. You will just be requiring the drafters to do it for you. Okay, let's see what's going on here. Sorry, yeah, change direction and remove material. Okay, so that's it. That's pretty much like what, let me see again the picture I have. Okay, this whole, oh, it's 4 of them actually. I just did 2. And then there is a standoff plate here. Let me see, and I've got a little bit of ribs there. Okay, well, I'm not far away from that. Remember, I'm not doing to size. I'm just, this is just a demo for this session. So I could come back here and go there and do the standoff. I'll do that at 110, whatever that standoff is, which is, let's say 20 was. It looked more than that. So this is just a quick demo to say you could generate things like this easily. I mean, I don't know, I can't remember how, and you could. Let's get a little bit more into the engineering side of it. This is the perhaps the drafting side of things. So what I'm going to do is, what CAD offers is that you should be able to check this out. Say this is engine block. Let me stop this far for this because of time. And I want to push this thing around. I want to see how it's going to be reacting or responding to pressure, which is very keen for an engineer. Engineer will be wanting to know how would this be responding under pressure, heat, and all that. But let's just do a quick one and not a complicated one. So within most of these applications, you should be able to run other simulations. Let me see if this will, because of the largeness of file. Yes, it could. I could start running a kind of finite element simulations on this, and which is I'm going to run it. This engineering. If you ignore the drafting part and say, well, I get drafters to do it, but this is engineering you. Now, most CAD files, so within like 10 minutes, I've generated that. I'm looking at it. So I can say, well, I want to run a process guide through what is happening here. Next is I want to set up my material. So I'm going to assign a material, and this is going to guide me. The one on SolidWorks may look slightly different, but it's still the same thing. The one on AutoCAD, if you got a version that could run simulations and all that, they are still the same, but it's just CAD offering you useful tools to do some certain things, take decisions, save your cost in testing. So assign material. Now, most of them, which is the good thing about CAD, most of them have got material library that you have basic materials, which is going to specify the Poisson ratio. Let's have a look here. I'm going to search for material. Sorry, no, I'm going to search for, I'm going into material. So I want more material. So I just hit a button there. Take me to, asking me, do you want legacy material? Because the CAD owners, these guys have populated some companies. The companies have been working for, they have material library where they put in a lot of the CAD manager or whoever loads up materials sizes. Let's have a look, just quick one. Legacy material, you could see aluminum 2014, aluminum 6061, brass, bronze, copper, epoxy, all these ferrite stuff, they're all there. Even steel, they're all there. They all stand legacy material, tungsten, carbide. So whichever material you are making, if you want your own custom-made bespoke material, you can add it. There's a way you could still add on a dip. So for today, let me just pick, let me go back a little bit, and then standard materials, you could see composites, it's gold, ceramics, glasses, anything, ferrous metal. You could see whole lot of family there, stainless steel, cast iron. So as I'm opening up, so that's the benefit. And then you could, instead of going to several iterations of calculations, you could just pick stuff there. So let me just put alloy steel, low alloy steel, just for my example's sake. Okay, and then once you double click there, it does select it there. And if you look, it's looking a bit faint. I'm not sure the screen is doing a great deal here, but is You got the density. Some of them you could change if you want to make your own. The Poisson's ratio, the Young modulus, all the, remember the strength of materials, all engineers, mechanical, electrical, chemical, all the 200 level stuff we did. So you remember all those kind of coefficient of thermal expansion. So they're all there. So you could, verify or say, hey, that's one of it. This is the B scope. You can also change the units the way you like. Okay. So I'm fine with low alloy steel. I'm okay with what is going there. And then I hit OK. So it ticks that button for me in this demo. Now, the next thing will be, if I say next, it's going to be ask me for constraints. How would this part or this equipment be held in service? How will it be? Okay, let's go next. Constraint. Possibly, you're going to know that this thing is going to be bolted down on the surface, and then the cylinders will be thrusting up and down there, to the top side to where it's going to be what you call have suction, have compression, you have the power cycle, and then you have the exhaust. So all those things are going to be happening. I just want to check pressure for the simplicity. I don't want to make a complicated one today. So, but constraint, I can just say create a constraint, and I'm going to hold this down here. It's going to ask me axis of translations, how I want it to be held. This is where you engineer, you need to understand what you're doing. So I don't want this thing to move in the X direction. I don't want it to move in the Y direction. I just want it to be fixed. It's more like a simple static run. Let's stay with that. So I've held that down there. Okay, I'm done. I don't want to overcomplicate it. Next, I want to put loads. So next is load, and load is pressure. You could put force if you want. You could put force. You could put pressure. Let me select pressure for a minute. So I want pressure to act in the cylinder there. And I want to rate it because I want to see whether it's going to yank it all off and blow it up. And so, and in this pressure one, you can have the luxury of setting it to any unit. Previous versions of this kind of softwares, you have to stick with one side of unit, whether you're SI unit or your Imperial unit, you are locked in there. But these days, most of the versions you can alter, you can move from unit to unit, but you got to be careful that you're moving from unit to unit, and then remember what you made your original model from, so that your measurements will be correct. But it's doable. Let me say, in the industry, we talk about PSI a lot. So let me talk about PSI. Let me just say 2000 PSI pressure. It could be bar, it could be anything. I don't know how it's going to stand. I've not done this with size. So let's say, okay, you can actually preview. You could preview. You could see the pressures are acting there in that. Okay, this is very keen for engineering. So I'm fine with this one. Take that part. So I've set material, I've set constraint, I've set load. What is next? To run. So next is to run the analysis. So I'm going to run an analysis quickly. It might take a little while because of the cooling fins and all the things. There's no thermal run for now. This is just pressure. I'm just thinking it's going to be at room temperature, but later on we get it to a bit more complicated if we have time and put temperature components and all that kind of thing. So, but yes, and it's going to take a little while to also run if you put more constraints and more boundary conditions and all the rest of them. But this is just the tools in the hands of engineers to check, push things around and look at what you're doing, try out your concept. It's running behind the scenes, so it's quite a little big while. Before, you would have to do some mesh systems and mesh it and all that, but these ones will do it automatically. Most of the CAD files today have been updated to do it automatically, just to simplify life for the engineer as you go along. So if it was a straight tube, would have finished by now, but because I have those cooling fins all over the place, remember this is a part we are analyzing. It's a little bit complicated and it's taking its time. It's solving a lot of equations, it's resolving a lot of triangle rule of forces, trying to crack a lot of things to be able to arrive at the answer. So we would wait a little while. Good news. If you think about this, let me just zoom in here. If you think about this, so run completed, that's fine. Tell me on Saturday, the 5th of December, 2022 at 17:04, run was completed, and that's my analysis here. Good news. Now I want to show something here. Let me go here. I like showing the number of equations this thing has. Let me see. Okay. Here in my echo somewhere. What am I? A little bit of information on the number of, this is what I'm looking for. Number of equations this has cranked on. So look at that. We couldn't do this with simple, there's no amount of maths or calculations you could do. This is at the hand of engineers processing this. Total number of equations solved, 135,400, and here's where I'm going. You know, at pass 2, it does one single pass, adaptive, second pass. Total number of equations this has solved and is 135,435. That's quite, I don't know anyone who would have done that in this time. Okay, so close that, and then let's go to next one is to show our results. So let's do results. I pull up the results and see how it's faring. This is a simple, very simplified analysis I have done. So it's just, hope somebody's not tripped off my system here. Okay. Let me see again. Where is, okay, sorry. Here is again. So that pressure this is exaggerated. I've done, let me close that. But this is an animation of that, trying to screaming off the head here. Don't know how it's showing on your screen. It's bleeding severely here, but you could see this range of, let me close this on so that we can just stay with 2. This is seen inside. I might as well close this one. I don't need it for now. Let me just stay with this. You could analyze it in terms of the maximum displacement when this pressure is going to move. What might be very interesting is I will try and get it in a graphical mode too, so that we could see. So, but you could see, let's see, I'm not needing displacement now. Let me go to make it I need stress. And I need it, I need just von Mises stress. This, like, I apologize to you a little earlier on for those in mechanical. You remember that. Let me pull. So it's in that. Hold on a minute. I need to back up. My results. Sorry. I'll cancel this one. Okay. Edit. I want this to be stress and von Mises. Okay, now and show. Yes. Right. So this on the right hand side is telling me the stress level that this has experienced. You could actually reformat this if you want to. If you know how to play around with this, you could see whether this is an acceptance criteria of what you want. For example, let me just double click here and say, I want the maximum stress that I could see with respect to, remember it's measuring it in that pounds per second square. So I want it to be 100,000, for example. And then I hit enter. Yes. And then I want you to start it. Sorry, it's telling me it's lower than my original value. Edit again. I'm trying to edit it. Right. Let me just throw in a figure here. That is, I'm not doing this into size, 100 million. Or whatever. Okay, that's okay now. That's very good. So yes, I want you to distribute. So if that is my benchmark up there, everything is cool, blue. I don't have a problem. It's 10 to power, sorry, 10 to power 7, 8 here is the maximum. So every stress, the highest one would have gone red, but there is none. So it's all detailed out. The point I'm making, because of time, I want to get away from here, is you could alter this and change the scale or change the material. If it was bleeding too badly, I said, no, well, this material cannot be suitable. For example, if it was something lower than that, let me still throw in one more when it's going to go kaput. Let me see, format this legend for me here. The lowest will be 100 or 10,000. That will be the lowest. And then go back there and the higher. Tell me, flag it off anywhere it is more than this. Flag it off red. So here you go. I've got that. So I've changed the criteria and it's bleeding severely means that that's going to be handcuffed. So we could alter things and reset the criteria or rerun to see when things have gone bad or when things are failing. So we could push it here and there. So engineers, we need this kind of tools in our hands to check our products out instead of running several versions of testing and spending money. We could just push it and know that, well, it's good to benchmark on something practical, but there are something that you just know that that's not a good, no good, that's a no-no. And we could take those quick decisions and then decide we wouldn't even pursue that route or we wouldn't even start off that way. There's no point looking at it. Let me do one more thing here before I leave this place. For presentation, you might look at, yes, let's say stress. In fact, sorry, let me go displacement this time. For presentation, if you want to see how this has moved, I'm going to select something magnitude, and I'll be looking at presenting it in a graph. Let's see if I can quickly get that bit done now, and I want it to be in X direction. Okay, let's see. No, phew. Sorry, forgive me. Let me open a new one. I want to see displacement and let me open it. It's dribbling me a little bit. I'm clicking something here, it's not responding. It's getting angry. Yeah, I want some in X axis and it's wasting my time. Okay, let me do edit again and then and displacement in X direction. And I want to select my curve length. Yeah. Want to see what is happening here. Want to see on this wall, on this edge, I want to see what is happening there. Okay. And then I don't want to toggle it. And then here we go. I want it to, I hope it's going to show me my, it's in graphical. Yeah. It's coming. Yes, it could plot the graph for me and show the displacement that has happened on that wall. So I could see the maximum along that curve, how it's bent away. So I could interpret it or further process it as an engineer. So that's, by the way, let me leave this because of time. I hope this is helpful to some people watching who are not used to these kind of systems. Let me quickly go to a promise I made here. I'll bring back my slide. I should have modeled some certain things and demonstrate how we can use, maybe in the question Q&A, if somebody, if we have the time, I can revisit how we can quickly update some things. And even on that model I've just shown, we can quickly run one and update that. I've been toying around with an idea, which I've pushed by the limits of CAD just to generate some things looking good. Said I'm going to be making a budget intercity transport. It doesn't exist at the moment yet in the world, I would say so. Though some variants of it is coming. Eco-friendly, overcome poor road infrastructure, be able to carry multiple passengers, capitalize on Africa's resources. This is for Nigerian market, utilize additive manufacturing mostly, and then be able to do 80 to 100 kilometers of journey distances, hopping from one city to the other, perhaps hopping from Enugu to Aba or Ibadan to Lagos, or Kano to Kaduna, kind of distances. A low medium level of license to run and reduce rechargeable duration. This is a dream I have. This is a dream I have. And I've generated something along that line. So let me see. I need to close up my CAD file here. Yeah, don't save. I don't need to save you. And thank you very much, Engine Block, for the day. And I want to go now to something. Okay. So this is my Suez Airways. And this is just to show what I have generated with CAD over the, just for, I'm going to produce this in maybe future. I'm looking to make good money out of it. For today, this is my solution to what is, by the way, the SOUS is my initials of my name, Sharp, Ugwuocha, and the WES part of it is going to be using wind energy, is going to be using electric, and it's going to be using solar power, as you could see. And then it's going to be strictly for passenger, no need for bad road and all that kind of things. Hopefully one day it's going to be in production. So count on me, and we'll share some part of the proceeds with Nigerian Society of Engineers in Glasgow branch. Okay, that's a good make something. So I have a solar bed here. Let me get my solar bed working properly. My solar bed. So I have a solar bed here, which is going to be some good square meters of solar energy that is going to be there. And then I have some of these blades are going to be propeller driven, and some of them are going to be static, so that they continue to rotate. and it will start, charging, pass through electric motor and start charging back the battery system that was charged. And then, so I have a combination of electric. Beneath this, what you are not seeing, which is another great way CAD can do. I'm not sure I have the time I didn't have much time to set it up in what we call configurations. So I could show you in configurations, but what I could do without going into configurations is hidden behind here. What I've done is, oh, I hope I've not done something silly here. So hidden behind, I've hidden lots of things. So let me unhide them again. Sure. I actually just wanted to show. Sure. Right. I'm back up again. And now show my rotor blades again. Rotor blades again. I've just cut off some to be able to. Forgive me for that. Right. Okay. Inside this, I've just hidden. They are not gone away yet, so they are somewhere there. What I've done here is, this is the only one I wanted to hide. Below here, and I'm going to bring out all my batteries. All this from here to here, my battery. I want to show them. Below here, there are series of battery that are loaded there. I can hide them. I have rack here. You can see how I've built this architecture over there, and then can hide the legs. Let me hide the legs. Hide the legs. So below here, the white batteries that are put up all these racks. They have batteries. For some strange reasons, I have hidden them. Heaps and heaps of batteries all over there. Show them. So they're all loaded down there. And each of them will be charged by, the electric system we are going. So all I'm saying is, this is a concept. Let me not waste too much time here. This is a concept, and it's I've been able to visualize it by the reason of CAD, and is going. So there are batteries leading here, and there are also solar inverters on the second rack. I may perhaps take time to open and show them in my presentation, and then bring out back these blades. So some of them will be active and propelling, and where some of them will be getting and recharging back the battery system within this. I don't know how well I'm doing with time, but I can already see some hands up. I can also do some modeling of, or showing some kind of things that, for example, you could check out some things in CAD. For example, let's see, just check that this blade is rotating. You can do all that. I can actually run a mechanism analysis to show this. I didn't have the time to generate a mechanism exercise to show these things are all working the way it should work. Okay, maybe I should stop so far and then see some questions. But the point I'm making is on the side that you could take things, your ideas, your things you're visualizing or in design intents, and then take them into kind of near end product. It's CAD aspects is very helpful, and we should be doing this, and engineers must embrace this. This is the way to go. like I said, very soon I will start printing my own cups and plates, costume made with my name and all that. So, but I'll just generate the card, feed it into the system. There are ways to evaluate that they are all working very well, and we will take it from there. Thank you very much. Let me pause so far.
Great. I think this has been a very awesome time. I mean, I was wondering whether to stop you or to say keep going on there, but it's been wonderful. Thank you for sharing these ideas with us. Thank you for sharing your innovative idea, especially, you know, ending it up on this very high note with your very wonderful innovation for the Nigerian markets, for Africa, and for use, of course, across the world to solve the transportation problems in different places. These are the kind of ideas we want for Nigerian engineers. These are the kind of things we get already. Nigerians everywhere are coming up with innovative ideas, and it's good to see this happening on this platform live as we speak this evening. Thank you also for the talk, the presentation, and for the demonstrations. There's a lot to take in here, and I've seen the chat has been quite busy. I'm sure you'll have many more questions and interactions after now. So I won't be taking much time. Just want to also still appreciate everyone who's been here. We've had up to about 90 something at the point, and up to 87 people still present. Thank you very much for your patience and interest. We've had people from different places across Nigeria. I've seen people posting their locations in the chats. We also have the Vice Chancellor of Landmark University. He's been very much here present. He's been making good comments as well. Talked about that the industry of the future will be industry of tiny tech, an industry of automation and the ideas of computer-aided designs like we've seen here. And I like the fact that, Engineer Sharp, you mentioned that Nigerians back in Nigeria, secondary school, people who finish secondary school leavers or with diploma, I mean, not bothering about too much degrees and qualification, can actually jump on this kind of ideas and use this software, understand how to work on CAD designs and manufacturing like this, and do it for companies wherever they are. The world is a global village. Ideas have no residence. So wherever you are, your idea can work anywhere in the world. And we always needed. Opportunities are everywhere. And for these things that are taking flight out of our country, we're getting expatriates and several other people with expertise from everywhere to work for us. We ought to begin to use these things to our own advantage. And it's good that our brother here has this idea and knowledge and experience. And many other people, I'm sure, within the NSC in the UK have so many of this knowledge. And I'm very sure we need to work on how to harness it together and probably arrange some training sessions across board different times to get people really empowered with this. Okay, I'm not going to talk too much.
Yeah, so. I think you are spot on there. That's what I wanted to just add as well, that in case I know we have different branches here from Nigeria. If you need further sort of for training in this area, please feel free to contact our branch. Then we'll make sure we direct you to Engineer Sharp accordingly. And we have different resources, as we said, we have in terms of human resources. There's nothing they make here that they cannot make in Nigeria. It's just all about that change of mindset for us to be sure that we have the capability, we have the skills. All we need to do is just to, step out there and get things done. So if you're interested to know further about in this area of the CAD CAM, and please feel free, universities or the branches, feel free to contact our branch. There's a possibility that Engineer Sharp can also fly down to Nigeria if possible. So, but feel free, send your details to contact us, then we'll be able to provide that support. We want Nigeria to change, as in change for good. Thank you.
Thank you very much, the chairman there. Chairman is also a mechanical engineer, and his experience is vast in things like this and many others. Perhaps with time, we'll begin to see more of presentations from our own people and the skills that they also have and how this can work for us back home. So I'll be handing over to my colleague who is standing by to handle the questions and answer and interaction session. Is the technical officer of the the Nigerian Society of Engineers, Glasgow branch, Engineer Fiver Wadawasina. Fiver, please take over from here now.
Thank you, Engineer Emmanuel and Engineer Sharp. Once more, that was a great presentation. Well done. So for the Q&A session, we're going to have it in 2 bits. I'll read out some of the questions and they post in groups of maybe 2 or 3. And then would also provide an opportunity for those that are raising their hands to ask their questions directly. So there's also been a request, and I think there's been a lot of people making the same requests. That is, if it's possible to get a copy of your presentation slide, Engineer Sharp. So a lot of the people in it, so you can answer that when you're answering the questions. The first question I have here is, what software are you using, please? The second one is, how can the indigenous engineer benefit from the advanced technology of CAD? And the third one, which is quite interesting, it seems picking an interest in your concept design you just shown, is, have you considered the weight of the batteries plus passengers plus solar panels plus wind turbines? And how is your analysis faring with that? So I'll just leave those ones and I can repeat any of them, Engineer Sharp, if you want. But yeah, if you can start with those ones, please.
Thank you very much. Very good questions. First one, CAD. The one I'm using here is PTC Creo 6.0. It's the software I'm using. There is a free version of it for students that could be deployed. You just follow some steps to download it. There are quite other free CAD softwares that are out there. Some of them are not robust as others. But this one, particular one I'm using is Creo, PTC Creo 6.0. It's used to be called Pro Engineer. So it's now called PTC Creo. So it's very good. I would recommend it if you're doing some mechanical designs and other. For those in civil engineering or building, they are, like I presented in my slides, there could be other more suitable versions of software, CAD softwares applicable. The second question was on the, what was the second question again?
It's how can the indigenous engineer benefit from the advanced technology of CAD?
The indigenous engineers, the way to start, I would say where to start would be to start from the free ones and getting training. That's the easiest way, just quick trainings, because it will pay off later on when you get yourself trained up to use those cards, softwares. You will save time overall, because even if you want to make changes to what you have generated, you can easily make changes and still store back the file. So the way they can benefit from this is just to start using them in simple things. It doesn't have to be expensive. When we can start with the card packages that are not expensive to get. Some of them are very expensive, but if we're doing small businesses that are trying to come up with ideas and generate some things, you can start with some basic cards that could get the job done. But that is the way to go, because most of them can talk to each other. In fact, what I'm going to say here is you can do something in Creo with this software I'm using, and then I get it sent out in step file or IGS file, and then it gets picked up in a different software like SolidWorks or AutoCAD, and then you can still open it up there and use it there. So able to go from one to the other exists. It exists. So somebody can say, I'm running my production. We have a system in SolidWorks, but you have Creo, or you have this. So you, as long as you set it up or save it in a file and transfer, you can transfer. That transferability is there. So they can start using it, particularly from those ones that are easy to get. The third question, I can remember the weight of everything. Yes, this is like a giant drone. as it were. If you take, I'm doing a simulation on the load as a matter of fact, but the output of the lift force and all those things, I'm still going through all that to lift it. So the bottom line is, imagine a concept of one battery lift one person. So below here, I don't know if so there are quite some. There are ultra light materials I'm using to make the casings and all the batteries and all the other materials that are going in there. But some of them are fiber reinforced, so they are hard, but they are not heavy, as it were. So they can't just break easily, but they are not. They are also light. New materials are coming up with the advent of 3D printing technology. It's unbelievable. It's unbelievable what is out there. I mean, the last time I ventured into these things, I saw things that were very incredible. So there are materials that look like plastic, but you can't break them. You can't, because they have been fiber reinforced and been manipulated in certain ways that, wow, it blows the mind. So they are promising. They can make things to be hard. Much of what I'm proposing here will be 3D printed, to be honest with you, for first trials, and then to stand the stability, the structural integrity, and of course be light enough to be lifted without compounding the as long as I have a weight to output ratio that is decent enough. What I mean by a weight to output ratio is, if the output from the solar panel can lift the solar panel, the whole of that solar bed, as spread wide as it is, overcome the drag forces against it, and provide sufficient enough energy balance. I mean, output. Say I require 10 kilowatts to lift it, and then it produces 20 kilowatts, which means I'm in a surplus of extra 10 kilowatts to power other systems. So that's a starting point. That's a good starting point. And then I look at all the turbine blades and each of them, and of course the batteries providing the energy to lift off that. So the concept is built from the small drone that is picking up a package, fly up. We're not looking at this thing flying in 32,000 feet. So it's going to be a special licensing regime, which is because it's going to just fly above, just somewhere within 2,000 feet to 5,000 feet, this guy. So that's not going to get going to higher altitudes. So it's not a big deal of lifts where it's going to consume all the energies. And bear in mind also, as it's rotating, as things stuff, and there's a chargeback from the so even when it's sitting on the air park, that's what I call them, spotting them around the cities, the solar energy will still be drawing in some energy, and there will still be some life going on. Okay, so yes, that is very good engineering question, but there is output to input ratio that is decent that I'm looking at in terms of overcoming all the weight, plus about 36 passengers inside it.
Okay. The next is I'll ask Lucas Hamidu to please unmute yourself. Thanks for your patience. I think he's been raising his hand for the last 30 minutes. So Lucas Hamidu, please, if you can unmute yourself and ask your question. Hello, Lucas. I think maybe he's no longer there. The next person is the VC of Landmark University. If you can please unmute yourself, sir, and ask your question.
Thank you, sir. Really want to appreciate the presenter and the organizer. I'm an agricultural. Landmark University is a private university of agriculture in Nigeria. I've always been telling my people that there is no way you will go in the way of agrarian revolution without serious agricultural mechanization and automation. And if we're going to do that, we have to go the way of what Engineer Sharp just delivered tonight, talking about CAD, CNC, and that of CAM. I know we didn't have time to dwell much area of CAM, but I remember he mentioned the issue of more of digital fabrication. And let me quickly agree with him that the industry of the future is not going to be that big or giant company somewhere. We are going to go the way of tiny technology. And I know a lot of that is already happening in India, it's already happening in China. At least those two countries, Nigeria can adapt. If we talk of US and UK, we may say maybe we don't have all the facilities that will make us go their way. But at least if you look at what is happening in India and what is happening in China, we can at least adapt that to our situation in Nigeria. But in any of this, we still have to go the way of CAD, CAM, and CNC, especially to save time. And so, once again, it is a good thing. But I think the area we should work on more, especially concerning our young engineers, is for them to build competence. And competence, to me, has four major components. One of such is what Engineer Sharp has done tonight. The first one is knowledge. Knowledge can only be imparted on us, but it takes us to go out and acquire skill. So in other words, knowledge is what we know, but what we do with what we know is that skill. Then the third one that will now come in is the issue of experience. You can imagine under how many minutes he was able to build that. It's because you have done it over time. So experience is what you have done or what you are learning from the experience of other people. But do you now know, out of all of these three, there is another one that a lot of our young people are not embracing. That is the right attitude. The right attitude. Thank God for knowledge, thank God for experience, thank God for skill. But do you know this program is supposed to start 5? I was rushing to make sure I make 5, even as a vice chancellor. And I forced my son, who is reading electrical engineering, also to be on this platform. So it's all about interest. It's all about creating right attitude, and our nation will be there. So once again, I want to thank you. I don't have questions, but just to appreciate everyone that has been part of this. When I saw that title, is captivating enough, at least to say that somebody is coming online or NSC Glassway coming to teach this. If you are going to pay, I don't know, maybe in Naira or in dollar, but honestly, it's been a refreshing time. And I just pray that we do more of this. As a university, we'll be getting across to NSC Glasgow, and we'll see what we can do together. Engineering is the bedrock of nation development. There is no two way to it. Thank you, and God bless.
Thank you, sir.
Thank you very much, sir.
Just for those questions, sorry, Fiverr, just for those questions, the question I didn't answer, some people asking about the slide. Yes, we'll provide, I will provide, we're very willing to issue the slide. Go ahead, sir.
Okay, no, I was just going to say thank you once more to the VC of Landmark University. Your comments are very much appreciated. And yes, we look forward to working with your university collaboratively in the future. So please feel free to contact us anytime. The next question was, which is better between Creo and SolidWorks? And I think once you answer that, maybe I'll ask, there are some few more people raising their hands. Yeah.
Wow, very tough question. They are pretty much the same, but I think SolidWorks will have an edge over Creo because of its the way it's positioned itself. There are some aspects I've used 2 of them competently. I mean, in my career life, there are some few things or few areas where Creo is better, and there are few areas where SolidWorks is better. So, but let me go by the amount of people that patronize them in the industry. Creo is, well, SolidWorks edges over Creo to some extent. Hold on a minute. Yeah.
Okay, thank you. I'll now call on Murtala Omirinde to unmute himself and ask his question, please. Are you still there, Murtala Omirinde? Okay, maybe we'll move to the next person. I'll call on Suleiman Imam. You can please unmute yourself and ask your question.
Good evening, everybody. I want to thank the presenter for giving us a bit of idea on engineering, on today's engineering design. I'm very happy for attending this. But I want to ask a question. I'm in power industry. Is there any other way that we can design all the fittings, accessories, and some of the materials we are using that can locally be made and withstand the technology of today through this? If there's a way they can incorporate NSE to the power sector in Nigeria, and then we have it done. I don't know. Can you hear me, sir?
Yeah, I can take. I think there's a place for that. The chairman will maybe comment more on that, on technical committees and things we've set up along that line. So there is a way.
Yeah, I mean, thanks for your question, Engineer Sulaiman. So what we've been doing as a branch is to work with the NSE, secretariat in Abuja, headquarters, to make sure that the NSE himself, if you're following up a lot of things that's been happening within the NSE, the president of the NSE now is a part of the committee which been, inaugurated and is now been assigned to be part of the energy group. People that are looking after how they can realize the vision of the energy in Nigeria. So for us as a branch, we've been working with the NSC president to make sure that vision come to life, come to reality. So, and we'll continue to do that. In terms of the question you asked specifically, we are open as a branch for anybody that, they want to approach us and they have the ideas and they need our expertise. We have a bunch of fantastic engineers in our branch, and not just even the NSA Glasgow, even as the NSA UK. You'll be amazed that there's nothing that is happening in Nigeria that we can't get done by just all these indigenous engineers, all these our people, from here. So we are ready, we are open. I've been working towards that. And all I'm going to say, just to encourage you, is to just keep track on what we are doing here. And if you have ideas, we have our emails and all that. Send it to us. Then if you have no people in organization you want us to approach on your behalf, or you've approached them on our behalf and you want us to take things to another level, we're really happy to do that. So that's all we can say for now, but we'll keep doing the right thing and keep the NSA in the right direction from what we can do from our own branch. Thank you.
Thank you for that.
Okay, I would now call on Patrick Ale. If you can please unmute yourself and ask your question.
Thank you, Mr. Presenter. I want to really appreciate the organizers of this webinar educative program. And I want to really appreciate the lecturer. I want to say that CAD is a very vast tool in engineering, particularly in areas of industrial manufacturing and other areas. I'm a civil engineer from University of Calabar. My question is that recently there is a new dimension into using bamboo as an alternative to steel reinforcement in building constructions. I want to ask the lecturer, how can we adequately use this CAD in the analysis of the strength of this alternative material, this is bamboo, in the construction industry? Looking at what is actually happening in Nigeria in terms of building collapse and other deficiencies, even using steel reinforcement, yet we have a lot of experiences in building collapse. How can we use this CAD in the analysis of the strength of this bamboo material? Once again, I want to say thank you for this opportunity. Thank you very much.
Okay, thank you very much. Very good question, sir. The way I will present it is as long as we have some reference points, in the sense that we can start off with a quick test, or whether it is hardness test or bending test or anything we can do just to generate the initial values we would need to check out what of course, the software can handle things like plastic, rubber, and all the rest family in terms of yield strength, in terms of it. But we can work out from there and begin to simulate various grades or ranges of values in terms of the yield strength or for bamboo or whatever material we have, and generate, because the software make provision for us to input our own value, and then it will work, backfeed it into the simulation to generate the kind of load or stress value that we'll be responding to. So there is, to answer your question, yes, there is a place for it. If we would do perhaps initial tests just to get a value, that if the answers of these values are already known, yes, then we are good to go. We can use this CAD file, put this initial values in there, and then run several iterations to be able to establish, yes, this is a good benchmark to assign for structures that will be made with bamboo. And then, of course, it will be a case of quality control. It's not too young bamboo, but we will have some kind of a place to how to standardize it, and then we can use it. That's doable. So the software makes provision for you to throw in anything you want to start off with, but we need to know what do we start off with. So there is a place for us to do that, and we can use it, save ourselves time for other hundreds of tests. We can use it and run several iterations of that test to be able to establish this is it. This is what we can do. Now, on the aspect of building collapsing, even when we are still using steel reinforcement, permit me to say this, I guess the point is not because steel was used, and it's a kind of not working to standard. Is the right aggregate used? Is the checks and balances in there to make sure that we have that quality control system, that what was specified on engineering drawing was what was implemented in the actual project? So I think it's more of those lack of quality control, or checking things, or building to standard. That's where our fault is, not to do with the material. So even if we are we find out that bamboo can work better or can still deliver or do something, the question then is somebody not cutting corners somewhere? or is somebody doing what they're supposed to do? So we will still have that challenge until we start doing things properly. Thank you.
Okay, we've got two more questions, but I'm just mindful of the time. Engineer Emmanuel, how much time do we still have? Can we still take two more questions, or?
Yeah, I was just going to ask if everyone is comfortable for us to add 10 or 15 minutes more, since the interactions seem interesting. I don't know. I'll send a poll shortly, so just go on.
Okay, just go on, yeah. Okay. So the next question, Engineer Sharp, is, does Creo use FEM or BEM for the modeling simulations?
It's FEM. It's more of FEM. It's not BIM. It's FEM.
So, and sorry, just for the rest of us that are not familiar with these acronyms, what's FEM and BEM?
Finite element modeling. So the B, I think, is built in something. So, but it's finite. I'm not sure if BIM. I know it's in kind of built in. It's more or less in structural terms, terminology. So BEM or bonded. Sorry, BEM could be even bonded. There are sometimes if you are doing I guess where he's going now. Sorry, BEM is bonded elements. Yes, it does that for parts, but in assembly mode, it won't use that bonded because it's not bonded, except you specify it is welded. So you can then use bonded. So the person that's asking the question will know the bonded element. It's if you're on a part, it will assume that all of them are all held together by a bonded mesh. But if you are on assembly, it will treat them separately.
Okay, thank you. The next question is, can you throw more light on taking the CAD model through CNC to CAM,
Good.
CAM? Any recommendation on packages for these two?
Yes, there are. There are quite, I would need to look at the best ones, even in Nigeria, or, there are quite a lot of CAM readers, but the question is, if you're not using a top-end CNC machine, 5R6, these kind of things, you may be, it might be an overkill at that in terms of that. So yes, there are. Okay, I wish I had time. I mean, we can run a few. What happens is that from CAD to CAM, you can generate just like this file. Imagine this file. I forgot to, well, I can still mention that things like this will be casted because of the blades and all that. Yeah, cast. It will be precision casting or something along that line. But if it's going to be a method where it's going to machine the whole, even after casting, yes, we can throw in this one and then get it to machine all the holes. Now, what happens at that point is you have at least two routes to go. You take it, give it to the CAM reader. The CAM reader will pick up the file, mark out the surfaces, the ASEX, all the points it's going to drill, and then work out the toolings is going to use, the drill size and all that. You work it out and it writes for you a sequence of how he's going to do. In fact, some of them can actually generate to you how the cutting, how he's going to be making the passes to cut the holes, how many times he's going to do to produce it, and the time he's going to take when he's going to swap from a small head to a bigger head and all that kind of thing. Now, the draft, when it's going to start, and then how it's going to progress. So the CAM reader will take this file I have generated, then populate it, get you, some of them can run a visualization of how it's going to progress, and some of them will just list to you the items you need to load and the sequence is going to go to run that. Now, some people who have a very fully automated system don't need to check or vet this thing again, because it could self, it could work itself out that way. But then some people who don't have that kind of automated system that can read CAD file and just start working with it would then take it up and then get their programmer to go and use that same file that you have programmed into a lesser efficient, well, say lesser, a lower end machine. It could be a simple CNC machine. It could be just some of these, a new version of lathe machine. So you could just put it on there, and then it has a console where you can type in all these programs that you have generated from the CAM reader. So it makes the job easy for you. Just the programmer just enters it there, and then it starts turning the parts out. But there are some systems that are just fully automated. It picks up the file, and then I don't have a copy on my machine here now. I could have just run a demo how it could pick it up, but there are quite some videos to watch where you can go from CAD to CAM. You could see it will write out details of how it's going to do the job and how long it's going to take it. In fact, it can suggest option 1, option 2, and then you could make your choice based on economics of what you have available.
Okay, thank you for that. I can see the poll result has come in, and we are only allowed to extend it by 10 minutes based on the majority. So I guess that leaves us with room for just one more question. I think I saw a hand being raised, a virtual hand, yes. So if I'll please call on Balbus, Ismail Balogun, please, if you can unmute yourself and ask your question. Thank you.
Yeah, good evening. Thank you for allowing me to raise a question. I appreciate the presenter, fantastic presentation. I have a very practical question. Will you rely so much on simulation or having a prototype?
But I will rely on having a prototype if the cost, yes, if to get past, there are several stages. You will need some proof of concept, your conceptualization and proof of concept. You can use prototype to get there. But when you get to validation testing, yes, we need a prototype to validate your design before you can then begin to head towards commercialization. So, but to answer your question, yes, I would rely more on prototype than just simulations.
Thank you. Thank you.
Okay.
Okay. I think considering the time, I think we I would say if we've got any other questions, we'll take your questions, and perhaps you can send an email to our inbox, and I'm sure Engineer Sharp will be happy to answer the questions. So I'll hand back over to Engineer Emmanuel to continue with the rounding up the rest of the program. Thank you.
Yeah, Dr. Emmanuel, you have to unmute yourself. I think you.
Yeah, just on that.
All right.
Thank you very much, Engineer Fiver, for handling that session so wonderfully. And very, very great thanks again to Engineer Sharp, Ugwuocha, for these inspiring moments we've had together with you discussing this very fundamental engineering topic and concept. Thank you very much. So I'll just give room for Engineer Sharp. If you're there, just 1 minute to give some final remarks on what do you think, how we're going to take this forward, what we can do, what can happen from now forward. We've heard people calling for interactions, for concrete ideas and plans and what can be done to move this on. I'll just give 1 minute as the speaker, as the facilitator today, to say something, and then the chairman would also add in. He said a lot already, but maybe just if you would want to still say much in addition, chairman. So for now, Engineer Sharp, 1 minute for final remarks. Engineer Sharp. Okay. Engineer Sharp, if you can just unmute yourself. So I was just giving you 1 more minute to give some final remarks. Sorry for taking you unawares with that.
Apologies, I went on a toilet break. Sorry. Okay. It's been a great opportunity, and I will advise and encourage everyone to get your hands on any CAD tool, start off anywhere, because that's the direction of the future. And if you need any assistance, you could call on the branch, and I will be very willing, along with the team members there, to help in any way we can. So thank you very much, and we hope to see Nigeria move forward in the area of industrialization, and to hit this industrialization level we are talking about. CAD has come to stay. That's the way the world is going. So
thank you.
Thank you very much.
Thank you very much. Chairman, sir, you still have something else to add, please?
No, I mean, yeah, just to say that to appreciate everyone that joined us today, joining us just now, and we appreciate you, even people that are able to stay back. We have 63 people still on tonight, so thank you. And if there's anything you want to discuss with us, please feel free to contact branch. Then we don't mind to do even another section of this, or even we can do presentation outside our own branch as well. Thank you. We are looking forward to have sort of partnership with different organizations, like the universities and different organizations where we can move Nigeria to another level. Thank you once again, and we hope that you'll hear more from us, and we'll look forward to hear more from you as well. Thank you. God bless. Bye.
Thanks a lot, Chair. I'll now call on the Secretary of the branch, Engineer Charles, who'll just give a vote of thanks, 1 minute, to thank the speaker, thank the attendees, the participants, and everyone. Engineer Charles. Engineer.
Thank you very much, everyone. Apologies, I was just on the mute today. Thank you for coming, and we sincerely do appreciate you. The chairman of Manchester, if you are here, that of London, if you are here, we so much appreciate you. And also, I still want to especially thank the VC of Landmark, the way you have raised some things there. Yeah, there are need for collaboration. Most of our other engineers who are looking to integrate, that need for collaboration is very, very much welcome. Please, we have our website. We have the contact email. I don't know if we can flash it for as many as are looking for that, so that, yeah, if you want to keep in touch, by all means, keep in touch. I have one of these gentlemen from Nigeria who is working on these what do you call it? These the prototype of what you call of the Osprey is it V22 Osprey? It's a helicopter. So information we are sought out. It was asked from so many people, and as at now they have run their prototype. Things is moving on well. So we so much appreciate your presence here, and we look forward to having you in our next meeting. Thank you very much, all of you. Thank you.
Thank you for that. Right. So I'll just run through some quick announcements. We only agreed to extend for 10 minutes, so I'll do this very quickly in 1 minute, right? This one goes, first of all, to members of the NSC Glasgow branch, and it's from the chairman of the branch. He's saying that I should let you know that certificates for those who have just recently been registered as corporate members of the NSC, that your certificates have been dispatched, and you should get the delivery in the coming days or next week in your postal, the postal addresses that you supplied. So watch out for that. And any other problem at all, reach out to the chairman. And this is from the Nigerian Society of Engineers London, UK branch. They're having the webinar on the 12th of December. That's next Saturday, actually, from 2 p.m. UK time and 3 p.m. West African time. The title is Sustainable Smart Cities, the need for a parametric planning, design, modeling, simulation, and visualization platform. This carries on very swiftly from what we've been talking about today, and I think is another area of application. So keep a date with the NSC London branch next Saturday from 2 p.m. And also from the NSC Manchester branch, UK here as well. They are having their 10th technical session the week before Christmas. That's just exact Friday before Christmas on the 18th of December. They're probably going to close the events for the UK branches this year. It's on the 18th of December, 10th technical session of the Manchester branch of the Nigerian Society of Engineers. The time is 5 p.m. UK time. That should be 6 p.m. West African time in Nigeria. The flyer will be out very shortly. Lastly, just to highlight again that the NSC Glasgow is out and available. So feel free to reach out to us. We have a YouTube channel where all these videos are uploaded. Video of today's program as well will be uploaded there. All our webinars we've had, these are the videos there. Just search for NSC Glasgow on YouTube and you can see those videos listed there. We're also on Twitter and you can easily reach us by sending us direct messages on Twitter. Follow our Twitter handle at NSC Glasgow. And the website is still under construction, but very much been updated gradually. It's www.nscglasgow.org.uk. We're ready for partnerships, for collaborations of different kinds, especially things like this that help to grow Nigeria, supply human resources, talents, and ideas, trainings, and all of these are things we're out to provide. So feel free to reach out to us through any of these platforms. On our website, you'll see phone numbers and email, which I've also shared in the chat for your records, so you can reach out to us whenever you want to. So that's all we have for today. And thank you for being with us, especially even those who have been with us from the very beginning of the webinar series this year. This is the last of it, and this is the close of our events of webinars for the year. I'm glad that we're ending it on such a wonderful note. It's a very remarkable one. We thank the speaker. We thank everyone who's worked behind the scenes, the members of the executive committee and our subcommittees, and all of you for attending. Without you, there would be no program. We appreciate your presence. Thank you very much and have a wonderful weekend,
Thank you.
wonderful Christmas, and a happy new year. Thank you.
Thank you. Goodbye.
Thanks for joining us tonight. Thank you.
Thank you very much.
Thank you very much from Nigeria.
Thank you. Goodbye.
From Nigeria.
Thank you.
Thank you for coming.
Thank you very much.
Thank you very much, and congratulations to NSC Glasgow.
Bye.
Thank you very much, sir.
Time for a good presentation.
Thank you very much. Thank you.
Yeah, thank you.
Thank you.
Bye-bye.
Thank you.
Well-organized webinar. Thank you to all.
Yeah.
Thank you, sir.
Yeah.
Thank you.
Thank you.
Really enjoy it. It's true.
Thank you.
Goodbye for now.
Goodbye.
All right. Bye-bye, Engineer Suleiman. Thank you.
You're welcome.